Okay, let's take a look at another video here in 8.3. We're on problem 3, and we did problem 2. Okay, so let's see. In problem 3, it says that a circular observation window on a marine science ship has a radius of 1 foot, and the center of the window is 8 feet below sea level. Find the hydrostatic force on the window, and note that the weight density of seawater is delta is 64 pounds per cubic foot. Okay, so let's see. I draw a picture. That's always the first thing that I'm doing for every single one of these problems here. I'm drawing a picture, and you know, that's step one. It says to draw the coordinate axes on the face of the plate, and then choose a convenient origin. So you got to draw a picture of this. Okay. Well, let's go ahead and center the observation window at the origin, and go up to 8 on the y-axis. By the way, whenever I have a circle, it's going to be most convenient for me to center a circle at the origin, right? Because I'll have to know the equation that's going to go inside the integral. So it's going to be you know, most convenient for me to have the center be at 0, 0 rather than some other spot that I got to use inside the integrand there. Okay, so you know, take note of that. Now, so we have this circle of radius 1, and x squared plus y squared equals 1. And now I'll need to solve this equation for x. Well, if I subtract y squared from both sides, x squared is equal to 1 minus y squared. And if I take the square root of both sides, don't forget about the plus or minus when we do that, x is plus or minus the square root of 1 minus y squared. Okay, that's the, so x positive means that you're going from 0 to the right, and then x negative means that you're going from 0 to the left. Okay, so you know, in the integral, why don't we go ahead and double x? You know, so that way we don't have a plus minus thing going on inside the integrand. So the width all the way across the circle is where I take x and I just double it. Okay, the positive x values. So 2 times x, or 2 times the square root of 1 minus y squared. That's going to be going in the integral. That's for w of y. Okay, and then I need to multiply this by a minus y. By the way, I'm in the U.S. system, so my answer, I can already know this, is going to be in pounds, right? Because I see feet, you know, here's delta, okay? Now, the delta value is, delta is the same as rho times g, right? And delta is 64, so that's going to go outside of my integral here, and I have 64 times the integral going from negative 1 to 1. Okay, so again, the bottom of the plate is at C, the top of the plate is at D. Well, yeah, from this picture here, I'm going from negative 1 to 1. And then in the integral, let's see, w of y, 2 is a constant. I can bring that outside the integral, right? I got the square root of 1 minus y squared left inside the integral. And then a minus y, a, again, is the top of the fluid. Okay? So the top of the fluid here is at 8 feet. Okay? So a is 8, and then 8 minus y, that's going to be the last part here then we want in the integrand. So this is the integral that I'll need to integrate. Well, 64 times 2 is 128. And let me go ahead and distribute the square root of 1 minus y squared into these two terms. Also, 8 is a constant. I can bring that outside the integral, right? So I got 128 times 8, that's 1,024. Times the integral going from negative 1 to 1 of the square root of 1 minus y squared dy and then minus 64 times 2 is 128, times the integral going from -1 to 1 of y times the square root of 1 minus y squared dy. Okay, so this is where I'm at right now. Now, the second integral, I can get that right away, actually, because this is an odd function. So if I replace y with a negative y, is that the same thing as a negative being in front of the function? So an odd function is if f of negative y is equal to negative f of y. Well, yeah, if I replace y with a negative y squared is the same as y squared, right? So I'd have negative y times the square root of 1 minus y squared. Well, that would be the same thing as throwing a negative in front of the function. Okay, so the point is that I have an odd function here. Now, the bounds are opposites. I'm going from -1 to 1. So the answer to this integral, the second one, is going to be 0. Okay, now I could, if I wanted to, use the u substitution and get the answer that way, which would be 0. Okay, but that's making it longer, more difficult than what it needs to be. Okay, so I guess the point of that is to say, look for those times where you can use things about even, odd in the integral, and also with this first integral here. Okay, so that first integral, I can do this one of two ways. Also, I could use a trig substitution. A is 1, right? So u would be sine theta. I could do that. Or the square root of 1 minus y squared, so that is half of a circle. That's this right half of the circle. Okay? And I'm evaluating this from -1 to 1. So the question is, what is the area of this half circle? Well, the area of a circle is pi r squared, right? The radius is 1. So pi, I need half of that. 1/2 times pi times 1 squared, or 1/2 pi, that'd be the answer to this integral. Again, so way quicker than using a trig substitution, this guy here. Now, if I were to use this trig substitution, I would still get the same answer. That would happen. Okay, but you can see that like I'm taking way too long to do it like that. Okay, so that's my point, is that look for those times where you can make the problem go quicker than what it would ordinarily take. Okay, so I've got 1024 times 1/2 times pi. That's then minus 0 from this integral. Half of 1024 is 512 times pi. Okay, that'd be the exact answer. 512 times pi is 1,608.5 roughly pounds for the units. And again, make sure that you're always given the units here in the answer. Okay, whether it's in pounds or in newtons, we must have that. Okay, so that's problem 3. Problem 4 is the last one here. Before we look at another topic in 8.3. But so in problem 4, I want us to find the fluid force on the vertical plate submerged in water. Okay, and of course I'm going to need an integral set up because this is a vertical plate. Okay, so here's a picture of the plate submerged in water. I'm 3 feet below, and I'll need the integral set up. Okay, and by the way, I'm in the U.S. customary system, right? Because the units here are in feet, so I can know right away that my answer is going to be in pounds. Once I'm ready to give the answer. So let's see. I chose the origin to be right here, and so this point is at 0, -4. This point is at 3, 0. This point up here would be at 0, 3. Okay, so let's see. I'm going to have 62.5 because I'm in the U.S. Customary system, okay, rather than the SI metric system. So I got delta, that's the same as rho times g, times the integral going from -4 to 0. Okay, so the bottom of the plate to the top of the plate, submerged in water, I'm going from -4 to 0. And then, let's see, so W of y, well, this line here is passing through 0, -4, and 3, 0. So the equation of the line is going to be what? Well, the slope of the line is 4/3. Okay, change in y over change in x. So the difference in the y values, I got -4 minus 0 divided by 0 minus 3. That's -4 divided by -3. That's 4/3. Okay. The y-intercept is at -4. So y equals 4/3 x minus 4. That's the equation of this line here. Now, I'll need to solve this for x, right? Because everything about my integral is going to be in terms of y. Never, ever about x for this stuff. Okay? So, well, if I add 4 and then multiply by 3/4, x is 3/4 times y plus 4. Okay, now I'm not doubling x because I don't have, you know, a plate on this side here. There's no symmetry on the graph, in other words. So, let's see, W of y, that's 3/4 times y plus 4, times a minus y. Okay, a, again, is going to be where the top of the fluid is at. The top of the fluid. So I'm 3 feet above where the plate is at. All right, so 3 minus y is what I put there. Okay. Now we'll need to integrate this this problem. And of course, don't forget about the dy there. Okay. So I guess the next thing I do is I factor out a 3/4. 62.5 times 3/4 is 46.875. And then when I FOIL out 3 minus y times y plus 4, let's see, 3 times 4 is 12. -4y plus 3y is -y, and then -y times y is -y squared. Okay, so then the next thing that I do is get the antiderivative, okay, this guy here, and now I'm plugging in the bounds. Well, when I plug in 0 first, every one of these numbers are going to be 0, right? So you're going to have 0 minus 46.875 times, when you plug in -4 into this here, I'm getting -104 divided by 3. Okay, so negative times negative is positive, and again, all of your answers in this section are going to be, actually in the entire chapter, are always going to be positive numbers. You got 1,025 pounds, okay? And here's where I'm showing you that information on the calculator there. So I got negative 46.875 times 12 times -4 minus 1/2 times -4 squared is 16 minus 1/3 times -4 cubed. We get 1,625 as the answer. Okay. Now, you know, there's multiple setups that you can do for these problems, but choose a convenient origin, right? Because your integral is depending on your picture that you've made. So I don't want a picture that's not scaled, you know, at the origin or something like that. That would be a brutal integral here for like any of these problems. Okay, but here's just another setup that you could consider. So what if we drew this picture instead of this one? Okay, like what if I had the bottom of the plate be at the origin, and then the top right corner is going to be at the point 3, 4. Okay, And then, let's see, 4 plus 3 is 7, right? So here's where the watermark is. It's 7 feet. And now the equation of this line here is 4/3 x, right? So the slope is, I'm going up 4 and to the right 3, 4/3, and times x. So I'm also going through the origin, right? Y equals 4/3 times x. Well, when I solve this for x is equal to 3/4 times y. I'm in the U.S. customary system, right? So 62.5 pounds per cubic foot is going to go outside the integral. And by the way, I sometimes see this, like where students have the units like all over the place. Don't say anything about the units until you get the answer. You know, like there's no reason to have any of that stuff until you get the answer, which is going to be either pounds or newtons. Okay, but I got 62.5 times the integral going from 0 to 4. Okay, so that's 0 is where the bottom of the plate is, 4 is where the top of the plate is, and then here's W of y. Okay, and then times A minus y. A is where the top of the fluid is at. So the top of the fluid is at 7, and 7 minus y. So if I were to compute this integral here, I should get the same answer. Okay, and by the way, this would be an easier setup, right? Because I don't have to FOIL anything out inside the integral. And that'll sometimes happen. So, you know, I guess the point of this is to say that you like how you do the problem totally depends on your picture that you're using. Okay, so make sure that the picture is most convenient for you to get set up and get the answer there. Okay, so let's go ahead and stop the video right here, and in the next video I'll start talking about moments and centers of mass, which is the other part of 8.3.